Okay, so what I'm going to talk about something is hopefully it's hopefully kind of revealing to you, and what I'm going to talk about is security overlays on sort of core protocols. So the internet was based on it was built on a day where everybody kind of knew everybody, and they based protocols on that. And there's two core protocols that one of which you're familiar with, and the other one you may not. So everyone here knows about DNS, right? And you talked about the security overlay with DNSSEC yesterday.
Yeah.
So I have a question about that. So how can you tell if a domain if it's secured right now from your web browser? But using DNSSEC. Nope. It's not to lock. Not to lock. So anyone have any ideas? Yes. What is it? It's not a certificate. Guess what? It's a trick question because you can't tell. So what I'm going to talk about is another thing you can't tell, and it's dealing with secure routing. So basically, we have two core internet protocols, neither of which have security built on them. DNS, which you know and love today, and routing, which ISPs actually is their bread and butter. Okay, and it's really, really hard to tell if you're compromised. It's really hard to tell if you're an end user or from an ISP. So I used to work for a company called VeriSign. What does VeriSign do? They issue certificates, right? And when you go to a website and you gotta go to your bank, for example, right? Do you look for that lock button? No? No, you don't look for the lock button. Why not? So, well, you should, but there's some caveats to it. So if you look at, when you go to a website and it gets that lock button for a certificate, what does that show you? They have a certificate, right? And it comes from a certificate authority. Do you know which certificate authority? How many do you think your browsers actually support? Hundreds of them. If you go look in your preferences, I just look on my Mac here right before I came up here. There was maybe 250, 300 certificate authorities in there, some of which I never saw before. And I don't know if I would trust them. So you look at that lock button. I've done this with my wife, and we do this in our houses. You look at that lock button, you right-click on it to see who the certificate authority is. And that tells you whether or not you have some sort of semblance of trust of that certificate vendor. Okay, so next thing. So sometimes you go to a website and the color of the lock changes. Yeah. Okay. You know why that color changes? It's because it's called the extended validation cert. What's the difference? There are three types of certificates out there. One's called domain verified. What does that mean? So someone came, asked for a certificate, sent it to a certificate authority, and said, hey, I actually have mail from this domain, and I want a certificate. And if they're willing to pay the money, and they can respond to that email, they get that certificate. Pretty high bar, huh? Okay. So another one's called a domain validated cert. The domain validated cert, that the certificate authority actually takes a look at it. Organizationally validated cert. And what happens there is they take a look at it and see whether or not that domain actually is vetted organizationally, comes from the right company, and that company is registered with some sort of business authority within that region. And that's actually a higher bar. But you as an end user, you don't see this. And the third type is extended validation cert. The various certificate authorities realized that, hey, look, this is a race to the bottom, because people are going to just look at this thing based on price because no one can tell the difference otherwise. We're going to create a list of standards. And what we're going to do is ask the browser manufacturers to actually change the way that it looks subtly so that you know that this is an extended validation cert. And you as a customer can feel somewhat comfortable that this cert has been vetted properly. But there's still two things underneath it that you rely on for things to work. One is DNS, and the other is routing. Anyone deal here with routing? Okay, we got 1, 2. All right. So have you guys seen any route hijack attempts? No?
Oh, that's right.
Okay.
Well, yes, have you seen?
So I'm going to describe one. So, and this happened a couple years ago. Anyone here hear about the Pakistani YouTube incident? So there was there's these mullahs in Pakistan got really offended about some content that was on YouTube. And so the government said to all the ISPs in Pakistan, you got to turn off YouTube. YouTube is no longer can be seen here in Pakistan. So what did the ISPs do? What they did is they created routes for YouTube that would basically send it to the bit bucket. So if any user within Pakistan actually went to try to go see YouTube, they would go try to connect to that website using that IP address, and it would go into the Neverland. You would never be able to connect. The problem was, as Pakistan Telecom is talking to other internet service providers, and it announced, and I'm going to talk about this, it announced, hey, I have the routes to YouTube. And so all the regional ISPs that are close to Pakistan Telecom said, cool, you're a lot closer than North America. I'm going to send you my traffic. And all of a sudden, people outside of Pakistan also couldn't get to YouTube. And people in Google actually saw this and said, oh my gosh, we got to fix this. And actually, that is a case where it was not malicious, but there are a couple other cases that have been, where traffic is actually routed through Eastern Europe, where it's kind of a little bit kind of funny, or it's going through places in Asia that maybe you wouldn't want it to go through. So let's talk a little bit about routing architecture and how this looks. So you basically have two things going on within routing, okay? One is you have an ISP. An ISP has a neighborhood. What you have here is a neighborhood, and all these connections are done using an internal routing protocol, IGP, okay? Now, when you talk to the internet in general, each of these clouds depicts an ISP, which is its own neighborhood. And you have connectivity that happens. You connect to various neighborhoods by people saying, I have these addresses in my neighborhood, and you have those addresses in yours. Let's exchange information, and let's make that happen. And that is by using a protocol called Border Gateway Protocol, BGP. And basically, A tells B all the destinations it has, B tells A its destinations. And if the two sort of correlate, you can communicate with each other. This protocol is not secure. In fact, there's this group in the ITF, it's called our group that makes the standards for the ITF, for the internet. It's called the ITF. And one of the people there said that this is essentially routing by rumor. So, you know how rumors start, right? And you know how they end, and they don't end very well. So we have this internet today that has lots of people you don't know about with lots of intermediates, and it's coming together. You really don't know if those people in the end are really telling the truth. So what are we going to do to create this thing so that people can actually be truthful? Because what you don't want to have happen is someone in Pakistan, tell me a country you don't like. Should we say the U.S.? No. Let's say someone like North Korea. Okay, North Korea, and they want your banking stuff because they need more money. So what do? So they'll hijack your routes, figure out a way to make the site look exactly what you want it to look like, and they'll figure out a way to get certificates so they got that lock on it, has the same look and feel, to get your user ID and your password, your email address, whatever else. And by the way, they can then attack your site and they get your money. Now that's kind of simplified, but that's definitely within the realm of possibilities, and it has happened. So there's we have We have a solution, and it's called RPKI. So the way that this works is the internet's a large place, and what you need to have is a scalable security infrastructure to be put into place. And what I'm not going to do is say, this is exactly what happens, because I'm really going to make you sleepy if I did that. So what I'm going to do is tell you kind of at a high level what goes on here and how this works. But basically you have these certificates, much like you have in your browsers, that are used to identify who the holders of those owners of those IP addresses and autonomous systems are. And then from those attachments, you can figure out who originates that route. Okay, so route origination, what that is you have all these neighbors that we were talking about earlier. That's where that particular IP address actually started from, that cloud that actually connected to the rest of the internet. And that is a place that you wanted to come from. Now, from the Pakistan telecom example, the cloud that it should have come from was in Mountain View, California, where it looked like the cloud that it actually lied about it actually came from Pakistan. And with the system that's coming up, you wouldn't be able to do that, because the cloud that you would actually validate through is that it needs to come through Mountain View. It cannot come from Pakistan. So what this does is, through this cryptology, it allows routers and other processes to actually validate the routes, so that you know where you got them from. This rumor stuff just goes away, and you can make this stuff happen. And there's a bunch of things that people talk about. One's called a trust anchor locator. Okay, that is the information that's used to identify where you get the certificate from, so you can validate these routes. And this content of information that describes where these originations occur is actually through a concept called repositories. So why are these important? You don't have to figure out, okay, exactly what all this stuff means, but you just, as you go through this, and hopefully I'm going to say some words that say, okay, when you finally do start looking into this, you say, oh yeah, he talked about repositories. I now kind of know what all this stuff works out. So what I'm going to do now is I'm going to give you sort of a pictorial example of how this works. And this mirrors the allocation hierarchy, how things work today on the internet. Basically, at the top, you have ICANN, okay? And then you have these regional registries below it. You have 5 of them. And then you have ISPs at various levels underneath that, okay? So you may have ICANN, you have ARIN, you may have cable and wireless, or maybe there was, like, in this case, it may be ICANN, ARIN, something like AT&T, then cable and wireless coming down here. And then you have an ISP that might be local to the area. And basically that ISP that's local to the area says, hey, look, I have this certificate, and I want to do this assertion that this IP address only can come from that autonomous system number. Each neighborhood is identified by an autonomous system number, and these autonomous system numbers are unique. Okay, so each neighborhood, each cloud has a unique identifier associated with it, and each cloud has a number of IP addresses that come from it, okay? And then you go through this process of going through what's called asymmetric public key encryption, or in this case, signature validation, okay? And basically, what you do is you do this validation of making sure these assertions are correct, and you can follow this chain all the way to the top from ICANN, which is where the trust anchor locator is, because these things start at the top and come down, and you only need to have one configuration item at the very bottom to realize I have the entire internet and I can validate the entire thing. And so I'm going through this fairly quickly because there's a lot of crypto behind it, stuff that will actually make your eyes bleed, that we're not going to get into. So what is RPKI? What does it create? It creates a repository. And the repository has 4 different elements in it. One is a 3779 certificate. Whoopie-doo. What does that mean? That means that you have IP addresses and autonomous system numbers in that certificate. And those autonomous system numbers in those IP addresses, both v4 and v6, say, I am the ISP that currently holds that space. Nobody else can have a certificate like that, okay? And then there's these things called ROAs. And those ROAs tie the origin, the autonomous system number you're coming from, and the networks that come from that. And they can only be signed by those 3779 certs above. Then you have things called certificate revocation lists, CRLs, and manifest records. CRLs are, my certificate got compromised. I need to stop using this one. How do I create another one? And that's using CRLs. And then there's manifest records that are used saying, hey, look, I have a manifest. You know what a manifest is like on a ship, right? Here are all the contents I have on the boat. The same thing goes with manifest records here. Here are all the 3779s, ROAs, and CRLs I have on my boat. And it's all in the repository. And using that, you can actually create a map of the internet. Now, if you're a geek, you say, wow, look at all that gobbledygook. Does anyone create file names like this? It's pretty undescriptive, right? But if you look at the far right side, it's kind of like DOS. You have your file types, right? So you have your ROAs, your certificates with CER. You have your .CRL, which is your certificate revocation list. You have the MNF, which is your manifest, and then you have your ROA. So that's the way that these things look for the technical guys. So you say, okay, great. So what do I do with these things? Well, what these things are done is that there's all these repositories around the world. Each regional registry will have one. Perhaps an ISP or two will have one as well. And to get a full mapping, you have to pull all these repositories down to your site. And then you have to validate it, making sure that all the certificates are valid. And based on that, you have essentially you have routing information. Then you check that against your routes that you've actually listened to across the internet. And you can say, okay, is this route valid, invalid, or unknown? Valid means, yes, I got a certificate that shows that this information is correct. It's good to go. Invalid means the certificate and what I actually see on the internet are two different things. Therefore, someone's lying. And those are things that you need to look out for. And then unknown is the case where those people haven't put in RPKI yet. They're not playing yet in the game, so they're unsecured. And then each ISP, Digicel, cable and wireless, well, I guess it's called line, it can actually figure out exactly what they want to do, okay, with these routes. They can throw them away. They can depreference them, a bunch of things that router guys like to do. So this is kind of what the flow looks like. So you have this web interface where you provision this stuff, where you create these ROAs. It gets reflected in a repository. Then you have these repository aggregators that get all this information from all these different repositories from around the world, run it through a validator, and with the validated entries, you can do your route checking. And based on the local policy, you can figure out what you want to do with those results. So that, in a nutshell, is the ecosystem of this RPKI system. So it's fairly simple in some ways, that you have this cryptographic way of actually looking at this information, and then you can actually check it against your routers to see if the information that's received is correct. Okay, so here comes a trick question. Can an end user see if these things are validated? No. Can ISP see that they're validated? So this is not a trick question, so the answer is yes. All right, so anyways, that's kind of the way that it's currently looking. What I'm going to describe now is the ways that those who are interested, who can participate in this, and that's on the provisioning side. The first part of this is, hey, I want to start playing in the system. I want it to put in my routes, and I want to make sure that they're good. So, and just like the way the internet goes, it's not easy because you have a bunch of choices. And it's kind of like the Papa Bear, Mama Bear, Baby Bear business again. But the easiest by far is the hosted system, okay? It's something you don't really have to learn a lot about RPKI to participate in. You just follow the prompts and away you go. For larger ISPs, you may want to use a RESTful service. Anyone familiar with the RESTful service? Anyone played with that? So geeks do. It's basically it's an API that people have so they can create programs to deal with this with tools across the board. Amazon has it for their web services. Google has it for their services. If you want to automate something, you'll use a RESTful service. And the last one here is delegated using up-down, which is extremely complicated, and only a couple of brave people have tried to do this, of which one has failed. So let's go through this. Hosted RPKI. It's easy to use and it's ARIN Managed. You don't have to worry about anything. You just put it in the systems. The cons are is there's no support for downstream. So if you're AT&T and you give them space to some downstream ISP, AT&T has to take care of it for you. We can add this support if we needed to, but we haven't had any customers ask for it yet. It's tedious if you have a large network and you want to do this, and you'll see why in a little bit. And the last thing is security. People don't like the idea of using us holding your private key. In the security world, when you assert holdership over something, you have the private key. And if you don't hold the private key, then how do you know that this is really the person that holds that certificate? But we have to have it for technical reasons. The hosted RPKI with the RESTful interface is a way of automating this. We still manage everything for you, but you have some tool sets that you can use to run your entire network through. And delegated, it has one positive thing in that you hold your own private key, but you run into lots of other issues. And it's really, really hard to set up. It's hard to operate, and you'll see why in a little bit later. Okay, so here's what it looks like in a hosted RPKI environment. You come to ARIN, you register yourself, you become a network contact. You then at that point you say, okay, I have control of the resources within your organization, your IP addresses and autonomous system numbers. And now you want to participate in RPKI. So you say, okay, I'm going to select hosted. I'm going to agree to the terms of service because we are now sort of injecting ourselves in your routing decisions in terms of making sure that if for your business to run, you're basically now saying, ARIN, you got to make sure your business runs. So there's some dependencies here, just full disclosure. So there's no longer this sort of, okay, once you get your IP addresses from a regional registry, you're done. And that regional registry isn't really needed much for anything anymore other than reverse DNS. Now it's very much integral within the routing decisions being made. So ARIN actually is going to play a more critical role going forward, as well as I can when this happens. So you go ahead and agree to the terms of service, and then you have to do some wifty crypto stuff. And there's essentially you have to create another set of keys that's used for basically two-factor authentication. The reason for this is that ARIN's board of directors realizes how important this system is. And they made ARIN Engineering actually create a system that we ourselves cannot change. So for example, you put in routing decisions into our system, there's no way I can go in there and change them. Maybe I wouldn't like your ISP, so I'm going to change your routing so you lose business because you dropped routes. There's no way cryptographically that I could do this. And there's no way that even a couple of people within ARIN staff can do this. We had to go through this high security module, do some programming, and make it so a way that only you can do this with a private key that you've generated here. Well, you sent us a public key. But this key is the magic keys to your kingdom to make changes to your RPKI infrastructure. We can't do anything about it. So if you come to us and say, can you change this for us? Well, our answer is no, we can't. You need to do this yourself. We can drop RPKI for you, and you can start over again, but we can't modify anything on your behalf. So it's a pretty big step. So once you've submitted that key, then you have all your certificates. Here's the number of networks you have, the number of autonomous systems you have. And you go on to the next page. And this next page has your row and name, which is administrative convenience. And this is for the routing guys here. Your origin AS, where this neighborhood, where that network actually came from. Your start date and end date, that's how long you want this thing to actually be valid for. And then you have your prefix. That's your network, right? Prefix slash, no, so you have your network and your prefix. And then you have this thing called max length. So the Pakistan Telecom incident, one of the things that they used is routing preferences with BGP is based on a number of different assertions or on preference. And one of the attributes, part of it, is more specific routes. So if you have a /23 announcement and a /24, which is the more specific? The /24, right? So it will honor the /24 announcement over the /23. In the YouTube incident, Google was announcing the /23. Pakistan Telecom announced the /24. So that's why you saw all these people swing over to Pakistan Telecom, was based on that announcement. And the way that YouTube/Google took care of that is they started announcing the more specifics. Now here, but when you do that, you increase your routing table because you have more announcements. To reduce this, what Google would have done is they would have set YouTube's prefix and the max length to 23. So they would have said prefix /23, max length 23, and that's the only announcement that you could see. And that attack would have been thwarted. And then this other stuff you see here down here below, the private key. Remember that public key that you created? There's all this HTML5 magic that occurs. You basically load the key, and then you can go ahead and it automatically signs things as you make the assertions. So here you have an example of actually creating a record with a max length of 24. Here's the prefix, max length 24. You can see that the key went from yellow to green, so the key's been loaded. And then it creates, it basically says, this is information we're going to submit to ARIN for this row to be signed, and it has to go through this high security module, which is this additional piece of cryptographic gear that we have. It's kind of slow. So that's why we don't tell you real time that everything's good to go. We'll notify you later. And here you see the message to that respect. So delegated up, down, I'm going to go through this really, really fast. You have to find a third-party provider who provides a service, of which there's only 2 right now. And there's lots and lots of documentation you need to read how to do this. You have to get your lawyers involved because there's things called a certificate practices statement that you have to put together. You have to do a bunch of other things as well. But once you have those things done, you can actually send us information through the system you use, and it's called an identity exchange. And once we get that identity exchange, we actually validate that's outside of RPKI to make sure you are who you say you are. And once that's done, you can go. So delegated up, down, you have to do a lot of work, Just not worth it right now, unless you're really a security conscious dude and you want to hold your own private key. Just a lot of work. And you can tell this by our statistics that we have on the number of people playing here. So the big things that you need to worry about is the number of certified organizations. ARIN right now has over 5,000 organizations. And you can see that 220 is actually a pretty small number compared to over 5,000 organizations. So there's a few people playing. This is very early in the game, so that's to be expected. Those are the number of rows they've done, 338. You can see over a history of time it increases. The number of resources that's covered is the number of networks that are covered. And you can see here at the bottom, up, down, delegated. It was 0 for a long time. 1 person joined, and 2 people joined, and frankly, we're down to 1 now because one party withdrew. And they're a large, knowledgeable company I have a lot of respect for, but they realize that this is hard work and that they're going to host it. So they, you can see here that there's work going on, and it's very early in the game, but there is a solution to the route hijacking stuff that's on the horizon. And and this talk is really not saying, okay, this is exactly how it works, and it's in really dry technical terms, but hopefully it's very high level, and you got some good words out of it. RPKI, manifests, 3779, certificates, route validation. Yeah. All right. So, any questions?
Okay, I don't see anybody's eyes bleeding yet. But I know you started going into it, Mark, but what would an ISP be thinking about the next steps in terms of getting involved in this or assessing whether this is something they wanted to participate in?
Yeah, but that's a really good question. So the first question that ISPs need to look at is, does my routing vendor support this concept? The good news is that most of the routing vendors actually do support this, and it's not in an experimental code either. It's in production code. So if you're an ISP and you want to go ahead and start playing with this internally, and that's what I suggest is you play with it first before you actually deploy it. There are ISPs that have deployed it and are looking at this from an experimental stage. And I only know of one ISP is looking at using this in a production stage where they're actually dropping routes right now. So there's, which is based in Europe actually. But everything else in North America is all experimental right now. So this is sort of advanced warning this is coming. This is further down the horizon, frankly, in my opinion, than V6. But there's definitely work underway to solve the routing security problem. And I know a lot of people are saying, so what is this stuff? And how is it used and how does that work? And so 3779 search manifest route validation. And then coming to ARIN or your regional registry to actually provision those things. So those are sort of the big take-homes. Hopefully people will get out of it.
You mentioned the YouTube incident in Pakistan.
Yeah.
I know you quite familiar with a lot of what happens in the.
There's, some of the victims of this may be places you like to go. So the victims are really sort of this. And frankly, ISPs, they only can see this if they're looking. So there's